Welcome back. In this lesson, we're covering control flow and functions, the tools that let you make decisions, repeat actions, and organize your code into reusable pieces. By the end, you'll know how to branch with if statements, repeat with loops, extract logic into functions, and combine all three into clean, readable programs. These are the building blocks that turn a sequence of statements into real program behavior. Let's get started. The if statement lets your program make decisions. The structure is simple. If, a condition in parentheses, then a block of code that runs when the condition is true. You can add an else block for what happens when it's false. In this example, if temperature is greater than 30, we print hot. Otherwise, we print not hot. The condition is a Boolean expression. It evaluates to true or false. The braces define which statements belong to each branch. Even when there's only one statement inside, always use braces. It prevents subtle bugs when you add more lines later. This is the most fundamental control flow tool in C++. Every program you write will use it. Loops let you repeat actions. The most common is the for loop. It has three parts in the parentheses: initialization, condition, and increment. In this example, we start with I equals 1. We continue as long as I is less than or equal to 5. After each iteration, we increment I. The body prints I, followed by a new line. So the output is 1, 2, 3, 4, 5, each on its own line. The for loop is ideal when you know how many times to iterate. For situations where you don't know in advance, C++ also offers while loops and do while loops. But for now, the counted for loop covers most beginner use cases. Once you find yourself writing the same logic in multiple places, it's time to extract a function. A function has a return type, a name, parameters, and a body. In this example, int square, taking int x, returning x times x. The return type is int. That's what the function gives back. The parameter x is the input. The body computes x times x and returns the result. Now, anywhere in your program, you can write square of 5 and get 25. The key insight? Functions let you name behavior. Instead of writing x times x everywhere, you write square of x. The name communicates intent. The function hides the implementation. This is the foundation of readable, maintainable code. Now let's combine all three concepts: a function, a loop, and a branch. We define a function called isEven that takes an integer and returns true if it's divisible by 2. The modulo operator, %, gives us the remainder. If value mod 2 equals 0, the number is even. In main, we loop from 1 to 10. For each number we call isEven. If it returns true, we print the number. The output: 2, 4, 6, 8, 10. All the even numbers. Notice how clean this reads. The function names the test. The loop provides the iteration. The if statement filters the results. Each piece has one job, and they compose together naturally. Let's scale up. This program processes a vector of exam scores and counts how many students passed. We have three functions. First, passed. Takes a score, returns true if it's 50 or above. Second, count passes. Takes a vector of scores by const reference, loops through them, and counts how many pass. Third, prints summary. Takes the scores and prints the count. The main function creates a vector calls print summary, and that's it. Notice how main reads like a summary of the program. You can understand what it does without reading any implementation details. This is the goal. Main tells the story, helper functions carry the details. As your programs grow, this pattern keeps them readable. Before we go further, 3 principles worth internalizing. First, use functions to name behavior. If you're writing a block of code that does something specific, give it a name. Even if you only call it once, the name makes the code self-documenting. Second, keep each function focused on one job. A function called countPasses should count passes. It shouldn't also print results or read input. One function, one responsibility. Third, prefer early returns to reduce nesting. Instead of wrapping your entire function body in an if block, check the failure condition first and return immediately. The remaining code runs at a lower indentation level, which is easier to read. These 3 habits will make every program you write cleaner and more maintainable. Here's the early return pattern in action. This function validates whether a score is between 0 and 100. Instead of writing one big if statement that checks both conditions at once, we check each boundary separately. If score is less than 0, return false immediately. If score is greater than 100, return false immediately. If we make it past both checks, the score is valid. Return true. Each check is simple, clear, and independent. Compare this to the alternative. If score is greater than or equal to 0 and score is less than or equal to 100, return true, else return false. That version works, but the early return version reads more naturally, especially as the number of checks grows. Guard clauses at the top, happy path at the bottom. When you have a fixed set of options, switch with enum class is cleaner than a chain of if statements. First, we define an enum class called menu choice with 3 values: add, remove, and quit. Enum class gives us type safety. These values can't accidentally convert to integers. Then we write a handle function that takes a menu choice and uses switch to dispatch to the right action. Each case matches one enum value and calls the appropriate function. The break statement prevents fall-through to the next case. This pattern is ideal for menus, state machines, command dispatchers, anywhere you have a closed set of known options. The compiler can even warn you if you forget to handle a case. How you pass parameters matters for both correctness and performance. 3 rules to start with. First, pass small values like int and double by value. They're cheap to copy, and the function gets its own independent copy. Second, pass large read-only objects by const reference. For example, a vector of integers. Const reference avoids copying the entire container while preventing the function from modifying it. The ampersand means reference, no copy. The const means read-only, no modification. Third, pass output targets by non-const reference, only when returning a value directly isn't practical. In most cases, just return the value. These 3 rules cover the vast majority of beginner function signatures. As you advance, you'll learn about move semantics and smart pointers, but these defaults will serve you well for now. When should you use switch versus if? Use switch when you're matching against a single value from a closed set of options. Menu choices, token kinds, state enums. These are all natural switch candidates. The compiler can optimize the dispatch, and it can warn you about missing cases. Use if chains when the conditions involve ranges, combinations, or unrelated predicates. For example, if temperature is above 30 and humidity is above 70. That's a compound condition involving two different variables. Switch can't express that. The rule of thumb: if you're testing one variable against a list of known constants, switch. If you're evaluating complex Boolean expressions, if. Both are tools. Use the one that makes your intent clearest.
Here's a practice exercise before you move on.
Take a program with a long main function full of loops and conditions and refactor it into 3 functions: one for input, one for computation, and one for output. The goal is to make main read like a 1-paragraph summary of the program. Read input, process data, print results. 3 function calls. If you can do that, you've internalized the core lesson of this chapter. For next topics, continue with strings and vectors to learn how C++ handles text and dynamic collections. Then, memory and ownership to understand how data lives and dies in C++ programs. Control flow and functions are the skeleton of every program. Now it's time to fill in the muscles. Thank you.